All right, so your aim for today is how do we model periodic behavior using simple harmonic motion? And the do now is the displacement of a mass suspended by a spring is modeled by the function y equals 5 sine 2 pi t, where y is measured in inches and t in seconds. Graph 2 periods of the displacement of the mass. Okay, so take 3 minutes and then we'll go over this question. All right, another 30 seconds or so. All right, so it's already if you're not done yet. I'm gonna go over the solution. All right, so our job was to graph 2 periods of 5 sine 2 pi t. So first thing I did was identify the period and the amplitude. So the period is 2 pi divided by this coefficient of t, which is 2 pi. So 2 pi divided by itself is just 1. And I did include the units here because that's given, it's in seconds. So 1 second would be the period. So it completes 1 cycle, in other words, in 1 second. The amplitude is going to be 5, and 5 inches is the unit. That just came from here, right? The number in front of sine, which is 5. Okay. For the table, it's your normal first row, 0 to 2 pi, and then from there, I divide everything by 2 pi. You get 0, 0.25, 0.5, 0.75, and 1. And then for the y-coordinates, normally for sine, 0, 1, 0, negative 1, 0. And then from there, you guys know that we have to multiply by 5 since the amplitude is 5 now. So it'll be 0, 5, 0, negative 5, 0. Okay, so the graph we're going to plot is going to have the following coordinates. We're going to have these x coordinates and then these y coordinates. So it'll be 0, 0, 0.255, 0.50, followed by 0.75, negative 5, which is here, then 1, 0. And then this question did ask for 2 periods, so we just continue the same thing, right? Same pattern. So as you can see, the x coordinates, the increment is going up by 0.25, or the increment is 0.25 each time. So we just go by 1.25, 1.5, 1.75, and 2. And yeah, it would follow that same pattern, right? It would go to the max, then 0, then min, 0, and then yeah. But the graph is technically, from 0 to 2. Technically, that will be our answer because we want 2 periods. Okay. All right. If you need to copy this down, please speak up or type something in the chat. Otherwise, I'll move on. Okay. So if no one needs it, I'll move on to the notes. All right. Just as an overview, so I'll show you the slide in a sec, but we're going to talk about simple harmonic motion today, which is one context in which sine and cosine is used in a physical setting, right? So you'll see this in physics class if you haven't yet already. Let me get to the notes for that. So just 2 slides, and then it'll be the classwork. All right. Can someone read this first part here? So you can just unmute yourself and yeah, just read it.
Simple harmonic motion. If the equation describing the displacement of an object at time t is y equals a sine, wait, what is that sign?
That letter is omega. Sorry.
Oh, omega t, or y, oh my God, y equals a cosine omega t, then the object is in simple harmonic motion.
All right, thank you. So yeah, that Greek letter is the last letter in the Greek alphabet, and that's the letter we use for the coefficient of t. So as you'll see here, it's like 2 pi over omega is equal to the period. And yeah, that's just in the context of simple harmonic motion. Like last week we saw it was like normally like sine kt, right? Or I think maybe we use b also, but just like another letter, right? But yeah, this time in simple harmonic motion, we're going to use this Greek letter, omega. Okay. All right. Can someone read the second part of the slide here?
In this case, amplitude equals the absolute value of A, maximum displacement of the object, period, 2 pi over omega, time required to complete one cycle, and frequency equals omega over 2 pi, number of cycles per unit of time in hertz.
Good, thank you. So everything's the same here besides frequency. So amplitude and period we've seen before. Frequency, if you notice, is just the reciprocal of period. Period is normally measured in seconds. And so frequency is 1 over second. So that's the unit. And the name for that is hertz, as I write here. So hertz. This is named after a 19th century German mathematician, physicist, one of my contemporaries. Yeah, so he actually proved the existence of electromagnetic waves, and this unit of frequency is named after him. All right, so actually, can you speak up or type something if you still need this slide? Okay. Also just note that, so if you do have a mic, it's actually easier if you just speak up, because otherwise I have to check the chat. So if you have a mic, just you can please speak up. That'll be easier on me for time-wise. All right, everyone got it? Yeah, okay. Also another thing, so I don't have everyone on my screen, so like if you do a thumbs up, I can't necessarily see you. So another reason to speak up if you need it, or type in the chat. I can also see that too. All right, so I'm gonna move on. Oh, someone type something? Okay, good. So second set of notes. All right, can someone read this for us?
The main difference between the two equations describing simple harmonic motion is the starting point. T equals 0, we get y equals a sine omega times 0 equals a times 0 equals 0, and y equals a cosine omega times 0 equals a times 1 equals a. In the first case, the motion starts with 0 displacement, whereas in the second case, the motion starts with a displacement at a maximum, the amplitude a.
Great, so thank you for that. So yeah, as you can see on the slide, there are two major contexts in which we use these equations for simple harmonic motion. First one being sine, it's as if we have the mass usually at the starting point of 0, right? If it's displaced already when we start the time, then we use cosine. So note here that we actually say maximum here. So, but it could also be a minimum, right? So it could also be like -5. Like, yeah, it just depends on like, let's say your 0 is here, then like your displacement is here, right? That'll be negative or positive, right? Or it could also be here. So just know that it could either be maximum or minimum. But either way, if it's maximum or minimum, then it would be a cosine function that we use to describe this motion. Okay, so while you're finishing copying that, let me tell you what's going on for the rest of the class. So after this, we're done with notes, and then it's just the classwork worksheet, which is on Google Classroom. So please go to that if you're done copying these notes. And we're gonna go over that on Wednesday. So tomorrow it's all remote. So yeah, we won't be meeting. So the next time we'll meet is on Wednesday, and we'll go over the classwork and the homework solutions. The other thing was regarding the quiz. So yeah, so sorry if you email me and I didn't get back to you. There's just like a whole bunch of emails about the quiz. Main thing, you know, of course, I know you guys are concerned about your grades. So as I said on Google Classroom, if you want me to regrade your quiz, I need you to be specific. So I need you to tell me which question do you want me to regrade. So if you go on Alex, it tells you, you know, which questions you got wrong. And then if there's a question like you're sure you got right and like your work's on Google Classroom, then I can go back and check and give you partial credit, right? There's one student, I rechecked her work and I gave her like 15 extra points. Okay, so like, yeah. So some of you have asked me for a curve, which I might do maybe, but I just want to make sure I regrade everyone first and then like see what the actual grades are before I give a curve. Okay, so again, if you want me to regrade any question on your quiz, you need to leave a private comment on your quiz 2 assessment on Google Classroom. Okay. Does anyone have questions about that?
I have a question, but not about the quiz. It's about the classwork sheet. It doesn't let me open it with Google Docs, so like I can't see like some of the equations.
Oh, so like, are you able to like see it, but like not see the equations, or?
I can see like the sheet, but for like the first question, it says modeled by the function, and there's like no function there, and there's no option to open it with Google Docs.
Okay, and there's no option to open in new window or anything like that? Because like if that happens, then I usually like just like download it, and then it allows me to like see the equations.
Yeah, I can open it in a new window and download it.
Okay, wait, so you said that's okay?
I can try.
Okay, all right, just let me know. All right, so people are saying in the chat you can open it in a new window. And yeah, so try that. But that's weird though. I did the same thing as for the other documents. Yeah. Okay. All right. So again, about the quiz, yeah, please leave a private comment. Let me know which questions you want me to grade for partial credit. And then, yeah, I'll take a look and yeah, I'm going to be fair and give you the points that you deserve. So outside of that, so some of you need to take the makeup quiz, like you were absent and you sent me an email last week, or you were like really late for whatever reason. If you are taking the makeup quiz, you should have gotten an email from me. Again, this is not for everyone, okay? Not like the last makeup quiz where I offered it to everyone, but this one is just for people who didn't have like the full 30 minutes because of technical issues or otherwise. But yeah, you should have gotten an email from me already. If you did have technical issues and you didn't get an email from me, you need to email me today, like right now, okay? So for the makeup quiz. But yeah, the makeup quiz is tomorrow at 2:30. Okay. Mason, wait, can you state your question in words or do you have a mic?
So just to be clear about what you just said, if we email you right now to take the makeup quiz, we could take it even if tomorrow at 2:30, even if we didn't have any like connection problems or something.
Oh, no. So yeah, what I was saying was like, so this is not open to everyone. This is only open to people who were not able to use the full 30 minutes because of technical issues. Like, yeah, I contacted the people that I saw in Alex, like they were like, we're in for like 20 minutes or something like that. So because of that, like I offered them the makeup quiz, but yeah, it's not for everyone. If you spent the 30 minutes, like the full 30 minutes, then yeah, this does not apply unless you like ran into like a huge bug or something. And like, but yeah, it's only for, yeah, people who had, didn't use all the time. Does that make sense?
Oh, Mr. Liang, when are you gonna do a review for the questions on the quiz? Because I don't know how to do one of them and sort of want to find out.
Oh, I probably won't do it in class, but if you, yeah, like you can ask me during SGI.
Well, what days do you have SGI, or is it every day?
It's every day, yeah. So yeah, it's actually 2:47 is when it starts. Yeah.
I'll probably hop in SGI tomorrow then. I got some stuff to do today.
Well, actually, tomorrow will not be good because that's when I'm holding the makeup quiz. So
Oh, Wednesday then.
yeah, Wednesday.
Mr. Liang, for these questions, do you want us to graph 1 period or 2?
If it doesn't specify, then 1 is fine.
Okay.
Okay, so I'm going to stop recording.